Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we are working on the August 2016 New York Algebra 1 Common Core Regents exam, problem number 14. If you want to access these exams anywhere in the world, go to nysedregents.org. Click on the appropriate tabs, and all the tests are freely available there. Here's the problem. A parking garage charges a base rate of $3.50 for up to 2 hours and an hourly rate for each additional hour. So the sign below gives the prices for up to 5 hours of parking. When I read these problems, I always look at the data. Just take a quick glance at it. Don't process it much more than that. So it says parking rates: 2 hours, 3 hours, 4 hours, 5 hours, and then it says 350, 9, 450, 1450, and 20. Then, which linear equation can be used to find x, the additional hourly parking rate? 9 plus 3x is 20, 9 plus 350x is 20, 2x plus 350 is 1450, and 2x plus 9 is 1450. Before we even get started on how to solve this problem, I think it's important to recognize that a lot of times people get this wrong because they don't even bother looking at what the x represents. All right, I'm not even kidding. That's the main reason that this problem ends up being wrong. Some people make x be the time. Some people make x be the time after 2 hours. Some people make x be the cost for the first 2 hours. Whatever they feel like making the x be, they make x be that. No, they defined x for us. It's the additional hourly parking rate. Okay, now that said, this is a real life situation, so we should be able to make a chart out of it. So time and then the cost. In the time is in hours and the cost is in dollars. Okay, so 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour, etc. 350 for an hour, 350 also for 2 hours, 9, 1450, and 20. And then whatever the next one happens to be. So they remember that x is the additional hourly parking rate. So it's the amount that it hops off from here to here. Okay, so from here to here, that's an increase of $5.50. Okay, that's $5.50. So that's also a hop of $5. So x is equal to 550. And a perfectly valid question that they could have asked you is, hey, what's the value of x? Okay, but now we know the value of x. But this lends us an opportunity to be able to solve this problem, even if we're not sure how to do this problem. We can solve each of these equations, and whichever gives us 550 can be the correct answer. And if only one answer gives us the correct answer, then it has to be the correct answer. But let's see if we can look at the structure of these equations. This 9 plus 3x equals 20. Okay, this is what this is saying. 9 is the cost after 3 hours. 20 is the cost of 5 hours. So here, 3 is would then be the number of additional hours. From 3 hours to 5 hours. After all, 3 times the amount of extra money is a monetary quantity. But there's not 3 hours between 3 hours and 5 hours. There's 2. So this is not the right answer. Looking at this, what this is doing is mixing up the data types. This is a money amount. This is a money amount. This is also a money amount. And this is a money amount. Okay, so here we're actually multiplying money times money, which is actually has units money squared, and it's also using the amount that the 2 hours parking is. So this is not actually multiplying an hourly rate times the number of hours. So this is not the right answer. Okay, so this one, 2x plus 350 equals 1450. Looks like here 1450. Let's erase a little bit here. 2x plus 350 equals 1450. This is a dollar amount here. This could be a number of hours. This is the initial right here. And this is the final. So right here, that's 1450. And that is in a span of 2 hours. Okay, so that is in fact the correct answer. Okay, just to check real quick, 2x plus 9 equals 1450. This is in the correct form, but there's not 2 hours between 3 hours and 4 hours. There's just 1 hour, so that's not the answer. So in fact, the answer is 3. Okay, I hope you got that. So we have an additional problem we created ourselves. A parking garage charges a base rate of $3.50 for up to 2 hours and an hourly rate for each additional hour. The sign below gives the prices for up to 5 hours of parking. This should look familiar. It's the same data from the previous problem. And now this one says, right, which linear relation could be used to find t, the amount of time a driver can park for $53. Okay, so if I make a time chart again and a cost chart, so time and cost. Okay, again, this is 2, 3, 4, 5, and it goes on 6, 350, 9, 14, 50, 20. Now, this again lends us a way of doing the problem because we know we hop by 550 each step. Okay? So if we don't know how to do this problem, we can literally just continue the chart. This is 2550. 7 hours will be, let's see, 2550 plus 550 is 31. And I can continue. And $53 isn't an enormous number. I should be able to get to $53 pretty quickly. So that's another way to do it. And that I recommend that you do that during the test. Remember, this is a multiple choice question. You don't have to do it the algebraic way. You don't have to. So what I will do though is I will look at this the algebraic way, and I'll recognize that this is a linear function, okay? But if we look at the structure of it, the additional extra time is $5. It costs $5.50. So the first 0 to 2 hours is actually a constant rate of $3.50. Each additional hour beyond 2 hours costs $5.50. So the number of additional hours is, so if t equals time parked, okay, then t minus 2 is equal to the additional time parked. After 2 hours. Okay, so what that means is that, hold on, I know YouTube videos sometimes block off the bottom, so let me actually go over here. I know it's working from right to left, but what this implies is that the cost is equal to the initial cost of $3.50 plus an additional $5.50 for every additional hour after 2, so it's t minus 2. So one possible equation that can get us the amount of time we can park for 53 hours is 53 is equal to 350 plus 550 times t minus 2. Okay, and we can look to see if this equation does appear in this list, and in fact it does. It's right here. So that is the answer. Okay, If this answer as is doesn't appear in the equation, in the one of the options, how it can appear is multiplied out. So this is just extra information, just so we know how to convert. So how do we convert from one version to another? We can literally use the distributive property. Okay, 350 plus 550 t minus 11. And so it can definitely appear as 350 minus 11 is negative 750 plus 550t. And that's another way that it may appear in this problem. There's a lot of ways that, in fact, that this equation can really appear. But it appears in the initial way. Just my point is that understand that when a problem comes up, you might have to do a little bit of extra manipulation to find the correct answer. All right. Hope you understood what's going on. Thanks for watching, and stay tuned for the next problem starting right now.